Today we start solving quadratics. Okay? Solving quadratics. And we're going to spend a week and a half solving quadratics. Because it's hard? No, because I actually know, well, I'm going to teach you 5 different ways to solve quadratics. Okay? Now, there's one way that works every time. So why don't I just teach you that one way and we get over it? It's not always easiest, right? The way that works every time is not always the easiest. And so if you're in certain situations, I want you to be able to recognize those situations so you know you can do it an easier way, quicker way. Okay? Does that make sense? Today we're going to talk about 3 of them. Okay? So what should that tell you? If you're in the right situation, those ways are super easy. Okay? If you recognize them, you got to recognize them. That's the thing. Okay? Now, the first way, first of all, before we talk about the first way, let's talk real quick about the fundamental theorem of algebra. Do you remember what that says? Have I ever said that to you before? The fundamental theorem of algebra? Okay, I have. All right. The fundamental theorem of algebra says that the highest exponent is how many solutions you should get. Okay? So for quadratics, how many solutions should we get? 2, right? 2 is our highest exponent. Quadratic, x squared, right? So I need to clarify that just a little bit because we could get 2 real solutions or 1 real solution or no real solutions. Okay? And I want you to see what that looks like so that you can recognize that. Okay? So first of all, can we talk about graphing? I told you there was 3 ways, right? So the first way can look just like this. What does it mean to find a solution of a quadratic? What does it mean to solve a quadratic? What are we looking for on a graph? So most likely these are going to be set equal to 0. So if y equals 0, where is that on the graph? Right? It's where it crosses the x-axis, isn't it? Aren't those points where y equals 0? Yeah? Okay. So if we set these equal to 0 and solve for x, what we're looking for are the solutions or the intercepts or the zeros or the roots. There's like 5 different names for it. Sorry, I didn't make that choice. Okay? I just have to help you figure out what it means. Okay? We're looking for the x-intercepts. So this is one way it could look. How else could it look? Well, it could look like this, right? So this has 2 solutions, right? Well, 2 real solutions. How many solutions does this have? 1, right? 1 solution or 1 real solution. What else could it look like? What's the only other option besides 2 solutions or 1 solution? No solutions. And what would that look like? Oh, okay, so it just doesn't cross the axis. It could be up there, it could be down here. It just doesn't cross the axis, right? So there's no solution, or more specifically, no real solution. Now, why am I being so specific about that? Well, if there's real solutions, doesn't it imply that there's something else? What? Fake solutions, so we don't call it fake. We call it something else, but I'm going to keep that till tomorrow. That's foreshadowing. Foreshadowing. Okay? But this is what 2 solutions look like. This is what 1 real solution looks like. Can I let you in on a hint? There's actually 2 solutions here. It's just 1 number that happens twice. Same number happens twice. We just say 1 real solution because it's only -2 or whatever it is. We don't say x equals -2, x equals -2, because that seems a bit redundant, right? So it looks like there's only one real solution, but we're smart enough to know that this is actually called a double root. God bless you. Okay. Now, no real solutions does imply that there are, I told you there has to be two, right? There are two. They're just not real. Again, foreshadowing for tomorrow. Okay? Any questions about this? So graphing is how we started. So what if I say that's the first way I'm going to actually teach you? Then you will jump up and down and be excited because you already know how to do it, right? If I give you an equation like this, x squared plus 5x plus 4 equals 0, what do we enter into the calculator? What do we enter? Do we put in x squared plus 5x plus 4 equals 0? Well, if we're solving it by graphing, it's already f of x equals, right? So we just put the equation in. I'm kind of ignoring the equals 0 because it already equals y, doesn't it? And what am I looking for? Where it crosses the x-axis, right? Let me see if this is going to be nice today. Ish. Where is it crossing the x-axis? -1 and -4? Yeah? X equals -1, x equals -4. Just to make sure, we could check, right? We could say Control T and look at my table. Look what happens at -1. What's y? And what happens at -4? Oh, see, I know for sure that that's the point of intersection, right? Where it intersects the axis, right? So I know for without a shadow of a doubt that this is my answer. Now, what kind of work would I show on this? Yeah, draw the graph. -1 and -4, right? Now, is that exactly what the graph looks like? No, it's close though, isn't it? And remember, we're not focused on exactly drawing a graph because we've already done that. I already know that you can do it. You've already proven that to me. So sketch me a graph that passed through the axis at -1 and -4. Yeah? Any questions about solving by graphing? Well, why don't we just use this every single time? So sometimes there's easier ways. Sometimes this way is hard, right? Why would it be hard? So what if this said that instead? Okay, where does it cross the axis? I can't tell for sure, but let's go look at the table. Control T. Surely I'll be able to find the zeros and the y on the table, right? Uh-oh. Can't. Okay. So when do I know I can solve it by graphing without a shadow of a doubt? First of all, when it says solve by graphing, we know we want to solve it by graphing, right? Typically, graphing is a way people check their work on some other ways because it's a super easy check if you already know the answers. Does that make sense? Okay. Otherwise, most of the time, if it says solve by graphing, then you know you can solve by graphing. But most of the other times, we want to solve it another way. Okay. Maybe we want to solve it by square roots. Well, what do I mean by solving it by square roots? Well, what if you had an equation that said this, x squared minus 36 equals 0? So we're going to solve by graphing if it says, right? How are we going to know to solve by square roots? What's not there? There's no x term. There's an x squared and there's a constant, but there's no x term, right? Well, if there's no x term, instead of getting it equal to 0, what if we just got the x squared term on one side and or the squared term on one side and the constant on the other? What if I did that? So what if I added 36 to both sides? X squared equals 36. How do I undo a squared? So if I take the square root of both sides, what do I get? Oh no. What times itself equals 36? I'm not disagreeing with you, but you're not remembering all of the answers. What else times itself equals 36? Negative 6. Plus or minus 36. Remember, when we put the root sign in the problem, we have to remember the plus or minus. Thank you. Yeah. Sometimes I can talk and write like a good teacher, other times. Thank you for catching that. I appreciate it. But you know what I'm trying to say, right? If we put the root sign in the problem, we have to remember the plus or minus. Got it? So what happens if it looks like this? It seems to be an x term in this problem, right? But what did I say over here? What did I want to isolate on one side? The squared term, right? What if we treated what was inside like just x? Isn't that a squared term? So this thing is squared, so to undo it, can't I just take the square root of it? Like that? Yeah, absolutely I can. What's left on the left-hand side of the equation? X plus 5, because if I square root something being squared, I just get the something, right? Equals what? Plus or minus 4. Now to solve for x, what do I have left to do? If I subtract 5 from both sides, I have to remember to do both of these things. I'm not going to just say plus or minus negative 1, am I? I'll do that if I'm lazy, and then I'll get it wrong every time, right? Because what is 4 minus 5? But what is negative 4 minus 5? Negative 9. See the difference? Okay. Can I show you one more example? Okay. What if it says 2 times x plus 1 squared equals 10? We already decided if it's a squared, I could just isolate that squared and undo it by a square root, right? People last period were trying to distribute this 2 through. Is that what I want to do? Don't I want to isolate this thing being squared? To isolate the thing being squared, what do I do with the 2? I divide it, right? I divide it away from the thing that's there. Because 2 divided by 2 is 1. So on the left-hand side, I just have x plus 1 squared equals 5. Yes? Now when I take the square root of both sides, now also we struggle again. What do I get on the left-hand side? X plus 1. What do I get on the right-hand side? So first of all, I get what? Plus or minus. Okay, you can't forget the plus or minus or you're going to get the problem wrong. I'll tell you that right now. Okay? Do you know the square root of 5? Neither do I. Leave it alone. How do I solve for x? If I subtract 1 from both sides, what do I get as my answer? Can I move this negative 1 inside of this root sign? No. This is like the protection of the 5, right? I just get negative 1 plus or minus the square root of 5. And that's it. That's all I want to do right now. If it says something to the effect of round to 2 decimal places or round to the 1,000th or something like that, then you know you want to put it in the calculator and find an exact nut. Well, this is more exact than a calculator because it's rounded, right? Okay? But otherwise, just stop here. Just stop here for now. Okay? Any questions about that? So that's already 2 ways, right? We're only 10 minutes into class and I've already taught you 2 ways to solve quadratics. The next one is your favorite. So there were so many cheers just then. I heard all of the cheers. I told you factoring would come back, didn't I? And I said, please understand factoring. So we got factoring and we're good. Yes? It's Navy. Is that okay? Okay. So how do we solve this question? Before, when I gave them to you, it was this, right? We practiced factoring. For days, we practiced factoring. Well, we practiced factoring for days like today. Okay? Because now it doesn't just say this, it says this. So what would you do if it was here? If it was just this, what would you do? AC and B, right? What is AC in this problem? 7, and what's B? -8. Now, I learned something interesting by watching your videos, okay? Because on the videos, somebody said ACX and BT. And for a while, I couldn't figure out what they were talking about. We have to find ACX and we had to find BT. And then I realized when I wrote this, I would write what multiplies to be AC and adds to be B. And somehow that just didn't cross over for them to realize that that was a multiplication and addition sign, and they just saw them as letters. So are you okay with that? I'm not trying to be disrespectful to that person. I'm trying to make sure that wasn't just a one-time thing and that you guys are all okay. Okay? So what 2 numbers multiply to be 7 and add to be -8? -1 and -7, right? Can we do the shortcut? Why can we do the shortcut? The leading coefficient is 1. If the leading coefficient is 1, we can go straight to the factors. Now, there's this thing called the zero product property that says if I multiply 2 things together and the answer is 0, what has to be true about at least one of these? What's the only way to get a 0 when I'm multiplying? One of them has to be 0, right? Well, the thing is that they could both be 0, right? And if I only make one of them 0, I'm forgetting one of the answers. So what I do is I set each one of them equal to 0 to see what makes each factor 0. So I add 1 to both sides, and I get x equals 1. And I add 7 to both sides to get x equals 7. Now, are these right? We didn't really talk about it back here because it wasn't really a situation where we needed to worry about it. But should we be checking these? Yeah, with a graph, I mean, the way to check is look again. I mean, I don't know, right? It's pretty obvious where it crosses the axis if we're solving by graphing, right? Square roots, we know the square root of 36 is 6 and -6. There's not really too much to check there, right? Okay, but here, what's 1 squared? What's 8 times 1? What's 1 minus 8? What's -7 plus 7? 0. So is 1 correct? Okay, 7 squared. 49, what's 8 times 7? So what's 49 minus 56? -7 plus 7. That one's also right. And not only are they right, but I'm sure they are right. Yes? One more? Okay. 6x squared plus 7x equals 20. I'm telling you to solve by factoring. That's going to be important today. Read the directions and see what they want you to do. Okay? Solve by factoring. What do I do first? What do I do first before I can do AC and B? Okay, so don't panic, right? Especially don't panic if you don't remember what to do, right? What does it have to equal for me to be able to factor it? 0. So if I subtract 20 from both sides, which is what I need to do first, I get 6x squared plus 7x minus 20 equals 0. Now I can continue to not panic, but now I also find AC and B, right? What's AC in this problem? Negative 120. And what's B? 7. Multiplies to be negative 120, adds to be 7, right? 1 and 120, 2 and 60, 3 and 40. What am I looking for? Combination that makes 7, right? Okay. 4 and 30, 5 and 22, 6 and 20, 8, 5 and 22 would be 17, but not 7. 8 and 15. Oh, yeah, I can stop there, right? Which one has to be negative? The 8, right? Because I have to end up with positive 7. So this will work, won't it? Can I do my shortcut? Not this time, right? I don't have a leading coefficient of 1, so I need to split my middle term into the two parts that I just figured out. Minus 8x plus 15x minus 20 equals 0. And now I can factor by grouping. Thank you. What's common in the first two? 2x. What's left when I divide out a 2x? God bless you. 3x minus 4. What's common in the second group? If I factor out a 5, what's left? 3x minus 4. Okay. Now, between this group and this group, what is common? 3x minus 4. And what's left if I divide out a 3x minus 4? 2x plus 5. Now, that's all fine and good. That's all factored now, right? But if we're solving by factoring, what do I have to do with each factor? I need to set it equal to 0, right? 0 product property. So if I add 4 to both sides, I get 3x equals 4. And then if I divide both sides by 3, I get x equals 4/3. If I subtract 5 from both sides, I get 2x equals negative 5. And if I divide both sides by 2, I get x equals negative 5/2. Now, should I check these? I should. Is it going to be easy? No, it's not. They're fractions, right? But we're not going to panic because that's rule number 1. Okay, no panicking. Just take your time, substitute it back in, check. Also, you have some help if you need it, right? Don't take this personal. It's business. Plug the number in, square it, multiply it by 6, then multiply it by 7 and add those two together. See if you get 20 as your answer. God bless you. God bless you. Okay? Any questions? We're good?